Okay, so let's continue. It says that Andy's rental charges an initial fee of $20. Oops, where's my little? I want to underline that, but I don't have. Why is that not working? Oh, because that's the wrong one. Got too many tablets up here. Okay, there we go. So Andy's rental car charges an initial fee of $20, and then an additional $30 per day. So those numbers are important. What is an initial fee? So these are linear equations, right? So we got to think in our head that our equations are going to be like y equals mx. Well, hold on, let me finish. Y equals mx plus b, but yes, you're correct. So the initial condition, what you start off with is always the b value. So whenever you see the word initial fee and you think that it's a linear equation, whatever that value is the initial condition, because that happens. You got to pay that no matter what. Now, the other one, whenever you see the word per something, like this is an additional means plus $30 per day. That is a rate of change. And what's the fancy math word for the rate of change with regard to this formula? No, the rate of change is also known as what? The slope. And what letter do we use for slope? M. So in this case, M equals 30. So if I write down what Andy's rental charges, and I start with y equals some value times x plus some other value, I'm going to put the m, which is 30 times x plus 20. And so that's the equation for Andy's car rental. Now let's do Buddy's rental. So Buddy's rental car charges an initial fee of $36. What did we say initial fee was? Yeah, but I mean, with regards to writing the equation, that is it's the y-intercept or b, okay, plus an additional charge of $28 per day. That's a rate of change. So what's that? Slope, or the letter m. So now for Buddy, his equation is going to be 36 for B, and then for M, it's going to be 28. And I'll write it this way. I'm writing it this way on purpose. So it's 28 times X plus 36. All that equals Y. And Y is the total, and X is the number of days. And Y represents the total cost. I'll just put dollar bills. Okay? So if I say I'm going to rent from Buddy and it's going to cost me so much, or I'm going to rent from Buddy for 6 days, I'm going on vacation, and I go, well, I need to figure out how much it's going to cost me to rent from Buddy's for 6 days. And I'm going to figure out how much it costs me to rent from Andy for 6 days. I have these two equations, I can plug it in. Now, most people will do this anyways. They'll say, well, it's $28 a day. 6 times 28 equals this, plus the additional 36. So if I give you a problem like that, most of you guys could figure it out. But the algebra is harder to learn, but it's easier to solve, if that makes sense. So the question is, what number of days is the total cost charged for the companies the same? Well, now this is interesting. I don't know what that value is, but the Y value is the total cost. And since Andy is set equal to Y, what I'm looking for is when does the expression 30x plus 20 That represents the total cost equal to the total cost of buddies, which is 28x plus 36. That's what I'm looking for. What value of x does that? Well, I have an equation with a bunch of numbers and one variable x. I can solve this. I can solve this and make it look like x equals some stuff. And how do I solve an equation and make it look like x equals some stuff? What's the main thing I do? I do the, help me finish this phrase. What do I do to move stuff to the other side of the equal sign? I do the, I've said it a gazillion times, I can't believe you guys don't remember it. I do the inverse. Now, if I'm adding in the original equation, what's the inverse of adding? Subtracting. If I'm multiplying, what is the inverse of multiplication? Dividing. So in order to solve this thing, I'm gonna move stuff. In other words, I got to get all the x's on one side and eventually get x by itself, and all the other stuff on the other side. So I have an x here and an x here. I need to move this 28x over to the other side. In other words, I need to make this equal 0. How do I make a positive 28x equal 0? Yeah, I'm just going to take negative 28x on this side. Now remember, whatever we do on one side, we have to do to the other. Now, technically, we said negative, but aren't we subtracting? Yeah. So here's one thing I want you to know is, and this isn't necessarily in the textbook, but what we're doing is we're doing the subtraction. We'll talk about this later, but I'm going to front end load it. This is a very important thing to remember. This is the subtraction property, and I want you to write this down if you can, of equality. So whenever we do something on an equation, we always have to do it to both sides of the equation, okay? So what I did is I said, okay, I'm going to subtract this from both sides. And when I do that, because, and the reason we call it equality, negative 28x is equal to negative 28x, isn't it? Yeah. So that's called the subtraction property of equality. Okay. So now when I subtract that, what is 28x minus 28x? 0x. Do I need to write the 0 down? Oh, it could be 0x or 0. Both are correct. But I don't need to write it down. So the only thing so these kind of cancel, and this remains over here as 36. Now what's 38 or 30 minus 28? 2, and then the x's don't go away. Now what about this plus 20? Just comes down. So we're getting there. So remember, my goal is to get x by itself and all the other stuff on the other side. Are we there yet? No. So what do? I got to either move the 2 or the 20. Remember, the coefficient of the variable, this is always last. Always do that last. So, because it's easier. So I want to move the 20 first. What is the 20 doing to x? Well, that's what we want to do, but what is it doing right now? When you look at this line, it's adding. So this is how you decide what to do. Originally, it's adding. So what is the inverse of adding? Subtracting. So I'm going to subtract what? 20, because that's what I want to move to the other side. And remember, whatever I do on one side, I got to do to the other. Now, if I were to say, what property of equality is that? What would you say? It's the subtraction property of equality. So now we've used this property twice. Okay. What's 20 minus 20? 0. What's 0 plus 2x? 2x. So this cancels, and I'm just left with 2x over here. Now, on the right-hand side of the equal sign, what's 36 minus 20? 16. Cool. Now, what is the 2 doing to the x? Dividing. I need to move the 2 away. Well, no. It's not dividing, guys. You got to listen to the question I'm saying. What does 2x mean? Well, a couple of people said dividing. Some people said multiplying. Some people said dividing. So you're definitely multiplying. What's the inverse of multiplying? Dividing. I think they were saying what I'm supposed to do next, and they weren't necessarily listening to the question. Okay. So now, before I do that, what property of equality would you say that is? Division property of equality. So I'm going to move this down here. Now, the reason I'm making a big deal out of it is because about 10% of the SAT, which you'll take when you're in the 11th grade, is literally knowing these properties. So if you memorize, and you know how often we talk about these properties? Almost never. There's a little section that we do at the beginning of the school year, and kids forget it. So I'm going to start incorporating it because it really does, it could increase your SAT score by quite a bit. So whatever we do, if we divide, it's the division property of equality. If we multiply on both sides, that's the multiplication property of equality. If we subtract, subtraction property of equality. If we add, addition property of equality. Whatever I do on one side, I have to do to the other. That's a nice way of saying this is a property of equality. Well, let's finish. What's 2 divided by 2? 0. Nope. 1. What's 1 times x? X. So this whole thing reduces down to x. What's this over here? 8. Now there's one thing that I could do, and we're not. I'm gonna show you this. You could always double check your work. Now, a really quick way to double check your work is to graph the original equations. So what I want you to do is turn on your handy dandy calculators. Okay, turn on your handy dandy calculators. I'll make this a big screen over here. Go to y equals, clear all this stuff out. There'll probably be some equations in there because. And so what was Andy's equation again? Y equals 30 x plus 20. Yeah, oops. Oh. And then Buddy's equation was 28x plus 36. And now if I hit graph, they look like they don't cross at all. Where does it say that they're going to cross? X equals, what was our solution? X equals what? X equals 8. So I need to have the graph over here at 8. So what I'm going to do is I'm going to go to Window, and I'm going to say X equals 0 for my minimum, and the maximum would be 10. Now we know that the y-intercepts are 20 and 36, so my minimum has to be 20, and my maximum I don't know what it would be. I would guess pretty high, so I'm going to make that 500. Okay, and now so remember, hit Window. I'll leave that up there for a second so you guys can plug it in your calculator. When you have it plugged in your calculator, hold your calculators up like this. So I know when I can move on to the next step. Okay, 0 to 10 for the x, min, and max, and then 20 to 500. Okay, 500 might be a bit high, but I don't feel like playing around with it today. So now I'm going to hit graph, and this is 1, 2, 3, 4, 5, 6, 7, 8. So doesn't it look like it crosses right here? Yeah. So what we're going to do, these top buttons all deal with graphing. So I'm going to hit second, trace. What's the word above trace? Calculate. So I'm going to let the calculator calculate the intersection. So hit second trace to get to the calculate menu, and then option number 5 is intersection. So when I do that, I think it's at 8. So I'm going to move this cursor to the right until this number down here gets pretty close to 8. Now, it might not land exactly on 8, but that's close enough. That's the first curve. I'm going to hit it again, the second curve. So what it's doing is it's marking the first graph and the second graph pretty close to 8. I'm going to guess, right? And then the calculator will tell me exactly what the answer is. Now, what that means is that they're both equal to 260 when x equals 8. Okay? And so I'm gonna paste that in your notes in just a second, and we'll take a look at it. Now, there's one other thing that I could show you on the calculator. Now, the other thing we could do is I could hit second table, which is the graph button. And we said when x equals 8, they both have the same value. So if I go down here to where x equals 8, see how this equals 260 and this equals 260? See how they both equal 260? So I'm gonna take a screenshot of that. And then I'm also gonna highlight that. Okay. And I'm going to put that over here. And so let's look at that in our notes. So I'm going to slide this back over here. Let me slide this over here. And so that's how we could double check our work. So we got the answer x equals 8 by using algebra. We double checked the answer by the graph. And then we also double checked it by the table. Now, if you did the algebra and then you went to graph it and it wasn't the same, you made a mistake somewhere. Okay? Now, in your homework, you're just going to have to do the algebra. Why am I showing you how to double check your work with the calculator? Because when you go to take a test, or the NWEA, or the SAT when you're in the 11th grade, you're going to have to make sure the answer is right. One way you could do that is graph it, do it real quick, see if it's right. If it's not right, odds are you made a simple math error. Okay? Any questions on that? I'll zoom